Hi, my name is Brian, and today I'm going to talk a little bit about assembling TinyTimer Kickstarter Edition. This video is primarily for my Kickstarter backers. I really appreciate your support and your patience. I'd like to remind you that I have added a lot of functionality to the design that was not originally in the design, but are things that I think are really important, like an input jack, like an output jack. So I originally went to shoot this video and I did not have the sound enabled. So this is the assembled TinyTimer, and I'll hold it way up here where you can see it. And this is the raw PCB. When you receive your TinyTimer, you will receive a series of parts, and you'll receive a pick sheet. For all intents and purposes, the parts will look something like this. They'll be individually bagged, depending on what kind of part they are. Well, not individually bagged, but they will be bagged. Similar types of components will go together, and things that need to go in foam will go in foam. As far as what you need to successfully assemble this, the most important thing is you need a high quality solder. So this is a Kester .030 solder. I recommend something similar to this. You need a really fine solder to do electronics work. I also think that it is extraordinarily helpful to have a solder holder like this, so that when you want solder, you just pull. You will need solder wick. You will need a pair of nippers, or these are some generic ones. There's several different varieties available. You get what you pay for. Those are okay. You will need something to clean the solder off of your soldering iron. I have a Weller dry cleaner. This has some brass wool in here, and basically as I solder, I just go like this and I stab this brass wool, and it removes any excess solder from the tip. It's great, doesn't require any water, and it's low maintenance. As an added benefit, it has a little spot here in the front of it that I use as sort of an electronics trash can. For the assembly portion of this, I did not use a vise. However, when I'm assembling projects, I normally use either this vise here, which I purchased on Amazon for about $25. It's a Bessie vise. Well, maybe it was more than $25, but it's a nice little vise. And I normally use this Panavise model. And what's nice about this Panavise, and here let me just zoom in so you can see it, is that you can adjust it and lock the boards in, and then it's very easy to flip it back and forth for assembly. So it basically acts as another set of hands. It's on a swivel base. It's very, very adjustable. And when I'm assembling boards, I regularly use it. For this project, I want to give you a good idea of what it's like to assemble this without fancy tools, and so I did it just using the countertop and using components for additional support. Once the unit is assembled, you will need a programmer. I am using a USB Tiny ISP. So if you email me and ask me, hey, I'm having trouble programming it, and you're not using this, I'm not going to be able to help you very much. I purchased this on eBay for about $10, heck of a deal. You do need a 6-pin cable, and this is very specific. If you don't have a 6-pin cable, you will have a heck of a time controlling TinyTimer. This is universally what I use for my boards to program them. If you have ordered a kit that is not assembled, it will not come programmed, so you will need a programmer. Let's see. I also am using a good soldering iron. I suppose you could do this with a really inexpensive 15-watt soldering iron, but I don't think you're going to get good results. So I'm using a Hakko 936. This is an older analog soldering station. There are a number of soldering stations available on eBay. They're very, very affordable. There's also a number of soldering stations available on Amazon. Just a little bit about my workbench. I have a large whiteboard that is in front of me, and I have a selection of parts that I keep in bins. So stay tuned. The assembly process takes about 45 minutes for me. I would anticipate that someone who has not assembled this 5 or 6 times, it would take you somewhere in the neighborhood of 45 minutes to an hour and a half. I recommend that you work slowly and carefully, and I appreciate your support. I appreciate you watching this video, and I hope that you enjoy the video. Video is narrated, and the first thing I'm doing is I'm taking a previous prototype and I'm going to remove this chip. This chip is about $10 as a single component, and it's about $6 in quantity. And what I do is I use a small screwdriver to get underneath the dip chip, and then I just sort of rock it back and forth, and that will pop the chip out of the socket. When I'm doing prototyping work, I often use sockets so that I don't waste chips. It's really common for there to be something not quite right with the board, or I move on and add additional features, and so I want my chips back. Now, I want to just point out these connectors have a specific direction, and what you're seeing here is I'm removing connectors, and you'll notice the wires go to the center of the board. And that's because I put that connector on backwards. So it's really important to pay attention to which way the wire side of the connectors faces when you assemble them, or you will be sorry, because you will find it very difficult, if not impossible, to put the connectors in. Okay, so when I pick a kit, I normally put the pick list down and I put the parts out on top of it. And I recommend that when you receive this that you do the same thing. I have my soldering station set to about 325 degrees Fahrenheit. And generally I work from the center out, and I work from the lowest to the highest components. First thing you need to do is there may be small protrusions on the board. You need to just clip those off with a pair of nippers. That's a normal part of the manufacturing process and will not occur on boards that are shipped out. So we're going to start with the ISP header because this is one of the more difficult components to install. And you'll notice that it is brass pins embedded in plastic. So one of the challenges is if you heat it up too much, the plastic lets go and the pins shift. So what I'm doing here is I have put the pin header in, and then I've turned the board upside down and just slid it over, and I'm using the board to hold itself onto the pins. It is important to work quickly with the soldering iron, and also to not push too hard, and when you take soldering iron away, you need to make sure that the you're holding the board down on the component, otherwise it may be loose. And you'll notice I'm using a couple of spare components just to sort of balance the board and make this a little bit easier. So what I'm going to first do is put my tip down and just heat up the pin and the pad, and then I'll drop some solder on it. And before I remove the board, I'll make sure that it's level with the component. So in this case, it looks like I felt that the components and the board were doing a good job of keeping themselves square to the header, so I didn't actually push down on it. So I'm going to go ahead and solder the rest of the pads on this. Okay, so the pin header went on there just fine, and next oh, you know what, it looks like I got a blob of solder into one of my pads, and so this is what the solder wick is for. Basically you hold that down and put soldering iron on top and push, and it will liquefy the solder, which then wicks into the copper. Now, copper is an excellent conductor of heat, so if you touch this, you will get burned. So you need to be careful when you're working with that. But solder wick is an indispensable part of soldering, and I strongly recommend that you have a high quality grade on hand when you're doing this. Okay, so the next component that I'm going to install is the microprocessor, and At one end of the microprocessor there is a small half circle indentation, and you'll want to line that up with the board. And the first pin to the right, so if you have the half moon facing away from you, the first pin to the right needs to be clipped. And what this does is it keys the chip so that it fits into the board only one way, and it helps you prevent installation backwards. So when you go to install this, the pins may not be exactly lined up. And if that's the case, what you need to do is you need to bend the pins just slightly. And the easiest way to do this is to use a flat, hard surface. And so it doesn't look like I've done a good job in the video. Oh, there you go. So you just put it at a 45-degree angle and just press with maybe 6 to 8 ounces of pressure. When you just barely feel the pins move, turn, do the other side, and then check the fit. And you may have to do this a couple of times. What you want to avoid is bending them too far, because it can be a challenge on a chip with this many pins to bend them back. Now, when you go to assemble this, you may find that the chip doesn't want to stay in there. And so one of the things you can do is you can take a small screwdriver and you can bend over a pin at each edge. And that will sort of hold the chip in place while you solder it. So you see I'm starting to do it with my fingernail. It's a little tough to do with a fingernail, so a small screwdriver is really good for that. And you just put it against the pin and push, and it just flattens the pen and bends it 90 degrees and holds the part in place so you can solder it. So, you know, this is where having a quality soldering iron and really small solder comes in handy. You need to have a soldering iron that can quickly bring the pad and the pin up to temperature, but that doesn't dump a ton of heat into it, because the parts are heat sensitive. You probably have 20 seconds a pin to solder this, and if you hold it too long, you can actually cause heat damage to the component. And if you hold it a really long time, you can cause heat damage to the pads and the board itself. So I'm going to go ahead and solder this on, and I'll be right back. Okay, so that took me about 3 minutes to solder on. The next thing I'm going to do is I'm going to solder the socket in place. It too has a small half circle indentation on it that should line up with the board. Just like the chip, you can bend over a pin at each end and it will hold it in place. So this should also take about 3 minutes to solder on, and I'll resume the video after it's soldered. Okay, so now I'm going to insert the LED driver chip in, and you want to line the pins up, and then you want to just push firmly down against a hard surface with 2 fingers, and that'll seat the chip. It's important to make sure the chip is seated properly, because otherwise it can be a real source of frustration. Next, I'm going to solder on the LED chips, and so I'll insert the single LED first. You do need to probably wiggle the pins a little bit to make this work with this footprint. The good news is it'll hold the chip firmly in place. You do need to insert the single digit before the 4-digit. And then once you have the single digit in there, you can install the 4-digit LED. The 4-digit LED does have a top and a bottom. So when you're looking at this, you want to look for the decimal places between the digits, and the decimal places are on the bottom. And so just make sure that is oriented correctly, and then insert that in there and go ahead and solder it in place. Okay, so next we're going to install the 16 megahertz crystal, and just insert that in there and then bend the pins over on the back side or the leads, and that will hold it in place while we solder it. And then we're going to install the small capacitors that support it. Interestingly, these were one of the components that required a revision because they were not wired correctly in the original schematic. And then next we're going to install the LEDs, but I needed to look at the schematic to remember which LED was red and which one was green. And it turns out that red is LED 1, which is to the right, and green is LED 2, which is to the left. Okay, so when you install the LEDs, you'll find that one pin is longer than the other. The long pin is the positive pin, and it should go towards the plus on the PCB. And I recommend that you insert both pins, insert the LED all the way down, and then just bend the pins over on the back side. And that will hold it in place while you are soldering. I'm also going to install the capacitor. It's marked 104. This is a power filtering capacitor, and it helps ensure that you're getting clean power supply to the circuits that are on the board. And again, just insert it into the holes and bend the pins over on the back side. And this is a good place to go ahead and solder, so that's what we're going to do. And you know, the position of the board is everything to being able to solder. So if you find that it's not the optimal orientation for you, go ahead and just turn the board so you can get the soldering iron and the solder in there. And as you solder, you will want to continue doing that. And one of the other things you can do is, as you solder, once you've soldered the leads, you can then bend them out of your way if you need to bend them to get to another component. And so you'll see here in just a second that I'll bend these leads up and out of my way and then change the orientation of the board so I can get the soldering iron in at the ideal angle. Alright, so the next step is to go ahead and straighten the leads out and then clip them off with your nippers. And this is really what the nippers are good for, is they enable you to get very close to the PCB when you're clipping the leads. And so you just clip those off and put them in some sort of trash receptacle, like you see me using this little space in my soldering iron tip cleaner for. Okay, so I'm going to move on to the next component, and in this particular case I'm going to start installing resistors. And what I do is insert the two leads through, and then I bend the pins over to keep them out of the way. In this case I have installed R6, which is a 20K resistor that is used for the LED driver. And then I'm going to move on to some of the other resistors at the bottom of the board. There's nothing magical about how these are installed, so I'm going to pause. I'll just skip over the actual inserting of those. So once I get enough components installed, then what I'll do is go ahead and solder them in. And sometimes, depending on the clearance, I may only put a couple of components in at a time. It's easier to work on them this way. So I'm going to go ahead and install some more of the resistors, and I'm just working through the components in the order that I'm most comfortable with. When I write the documentation for this, I'll document what I think makes the most sense for assembling the board and the components. Now, there's nothing magical about soldering the leads, so one of the things I've done to try and shorten this video is I have skipped over the repetitive part of soldering each lead and then trimming it off when I'm done. I think if you've seen me solder one lead, you've seen me solder all of them. And I'm basically working through the different resistors. The two resistors I just installed are used to limit the current that goes through the LEDs. They're 100 ohms apiece. And there's another resistor and capacitor next to them that are involved as a ripple filter on the controlled circuit side, which could be high voltage. So next I'm installing the capacitor that is used in the ripple filter, and this capacitor is rated for 600 volts even though the circuit is only rated for controlling 200 volts, and I strongly recommend that you keep it to 120 volts. As a safety precaution, the traces on the board are rated for 4 amps at 120 volts, so if you overload it you will destroy the board. I've tried to ensure an ample safety margin on all the components to help with the long life of the board. So at this stage, I'm going to go ahead and start soldering, and you can see I've got quite a few leads here that I'm working with, and I'll just kind of work my way through all the leads and then trim them. And again, this is a very repetitive process doing this. So now I've got a lot of the discrete components installed, and you'll notice that I bend some of the components back and forth as I'm working on the board. And that's okay to do to a certain extent, but just realize they're not that flexible, and if you bend it back and forth enough, you will fatigue the pins and break it off. Next, I'm inserting the diode. On the diode, there is a white band, and it needs to line up with the white band that's on the circuit board, otherwise the circuit will not work as expected. So I'm going to go ahead and solder that in. Okay, so next we're going to install the transistor, which is a BC517. It basically acts as an electronic switch. The pins on it are somewhat fragile. I am bending them by hand here, but that's rather difficult to do. A small pair of needle nose pliers will make extremely short work of this. Once you get the pins bent, you'll notice the transistor has a flat side to it, or it's sort of D-shaped, and that just needs to line up with the same outline that's on the board. And go ahead and work the pins into the board, and then solder them in place and trim the leads. Next, I'm going to go ahead and install the 3-pin header. And this is a selector that works with a dip switch to determine whether the system is in program or run mode. And it was a little bit of value engineering here. It replaced a switch which would have added more cost to the system. So I'm going to install the 3-pin header, and this acts as a switch on the board. And I'm going to use just a component that I have laying around to make sure that constant pressure is applied to that header while I solder it. You can use really anything. Again, the plastic and metal rules apply. Don't push too hard, don't stay too long, otherwise you will melt the pin header and cause problems. Next, I'm going to install the switches, and these go in fairly straightforward. They only fit in one direction. Just don't hold your fingers behind the board when you're pushing them through, otherwise it will poke you. And remember to solder them right away. You'll notice that I forget to do this, so I'll come back in a few minutes and solder these. Next, I'm going to install the 2-pin headers, and they're located in the lower right and upper and the mid left. It's important to pay attention to the orientation of these parts because the place where the wires attach needs to face out, and it will cause you no end of grief if you install them backwards. They are a plastic component, so it's important to make sure that you solder them quickly, and they do need to be held firmly against the board while you are soldering. But for the most part, the board they're tall enough that the board will just sit on top of them. So here you can see where the wires attach, and that's what the back looks like. So you can see here I've ensured that the wires face away from the center of the board, and then you just turn it upside down and it'll sit tight while you solder it. You will want to push down as you solder, and you'll see here in just a second. So I'm going to actually show you the soldering. So I'm pushing down and soldering at the same time. It takes a fair amount of solder for these, just a little bit bigger component. And then you'll notice that I switch to holding it with my fingers. Oh, actually, I guess I didn't do that on this and I didn't have any problems. But just, you want to pay attention to how these go in and make sure that they are firmly seated as they're soldered. Okay, so here I'm soldering this in place, and you'll actually see me hold this one down. So you see applying the solder there, and then I will switch and hold the board down just for a second while the solder cools, and that makes sure that the part doesn't move while the solder is cooling. It's possible for the part to pull out, and that's a huge nightmare that you want to prevent. It's also possible for the part to sit crooked, and that just looks sloppy. So next we're going to install the USB header. This is just used for 5-volt power. It's an inexpensive fitting. It's very durable. Cables are cheap, and practically everybody has a cell phone charger laying around that'll put out 5 volts USB. So when you solder this in place, be careful with the pins. They're very small, so work carefully and don't put a ton of solder on them. And when you go to do the outer pins, these are large and they do require a lot of solder. You're not going to overheat them because they are connected to the case, but this is what will firmly attach the socket to the board, and this is one of the reasons I like this connector. It's a very durable connector. It can take a lot of stress because these are very large hold down connectors. So I realized here I had forgotten to solder the switches in place, so I'm just going ahead and soldering those in place. So I'm going to go ahead and install the relay here, and this is a really straightforward component. You will need to press down and hold the board as you install each lead. It's actually rather important to make sure that the relay is firmly seated. When you have finished soldering the components, and you'll see here as I solder, I put a lot of solder on the pin, and then I will hold it down with my fingers and remove the soldering iron. Give it a second, let it cool, and that ensures that the component stays where I soldered it, and then I'll move on to the next lead. After you are done soldering this, I recommend that you trim the leads on the relay with your nippers to get it closer to the board so they're not sticking out. It just reduces the opportunity for them to come into contact with things or people. You know, again, this circuit is capable of controlling high voltage, and it is your responsibility as the installer or the assembler to make sure that it is installed in a safe location where people can't come into contact with that high voltage. Okay, so at this point we have assembled the TinyTimer Kickstarter edition, and I hope that you found this video interesting. I have cut the actual length of the video about in half, and by editing out some of the soldering. So here I'm going to connect the TinyTimer or the Tiny ISP to the header. There's a circle on the 6-pin ISP header that indicates the bottom, and it lines up roughly with where the cable needs to go. So you will need one of these programmers to program the board. If you've ordered this as an assembled kit, it will come programmed, and you'll be able to set the on-off timer values, and I'll be doing another video once I get that portion programmed. Thanks for watching, and have a great